I will begin.
What's the code?
The code is 4720. There, maybe now you can. Okay, so I will pray. Dear Father, we thank you again for this day. We thank you for this class. I just pray that you be with us today. Help us to glorify you in what we do. We thank you that even though we were sinners, you loved us, you died for us, and we thank you for your grace and mercy. And I just pray that you be with this class today, Lord. Help us to glorify you in what we do, Lord. In your name I pray, Lord Jesus. Amen. All right, so quadratic equations, right? So let's do some more. So I showed you last time that completing the square is a good way to solve a lot of these problems, right? But of course, sometimes, the quadratic formula is, worth using. So remember we had ax squared plus bx plus c equals to 0. We derived the solution is minus b plus or minus the square root of b squared minus 4ac all divided by 2a, right? And so this right here is the so-called quadratic formula. In contrast, this right up here is the quadratic equation. So how do we solve a quadratic equation? Well, it depends, right? There's a lot of different ways. Let me show you a few. So I'm going to start by examples where I think that using the quadratic formula would be misguided. All right, so let's see here. What if you're facing 3x minus 7 times 2x plus 3 equals to 0? All right. Should we multiply it out and use the quadratic formula? I sure hope not, right? What we should do is just use basic principle of algebra. If the product of two things equal to 0, that means either this is 0 or that is 0. So we just have to look at 3x minus 7 equal to 0 or 2x plus 3 equal to 0, right? And what do those give us? X equal to 7/3 or x equal to minus 3 over 2, right? So there's that, right? So if the problem is already factored, then don't fight it. Use the factoring principle. Other problems, right, might sort of be made to order in this sense. Like, what if you got 2x plus 3 squared equals to minus 17? So this one, right, you're definitely going to want to use the square root property, right? So we take the square root of both sides, and we get 2x plus 3 equals to plus or minus the square root of minus 17. But what is the square root? It's all good. The code's up there. The square root of minus 17, well, we can pull the minus out and make it an I, right? So we've got plus or minus I root 17. Okay? And so, so then I've got 2x is minus 3 plus or minus I root 17. And then final finishing blow here, divide by 2. What do you got? You've got x equals to minus 3 plus or minus I root 17 over 2. There you go. So if you already have a square, don't fight it. Use a square root property, right? If it's already factored, Let factoring be your guide, right? Still, there are other problems. I mean, there's some problems in your homework where it tells you to use the quadratic formula, which I think are kind of silly. So I've showed this to pretty much every section of college algebra. I'll show you guys as well. One of the homework problems was I'll find it eventually. Oh, there it is. So x minus 2 times x minus 10 equals to minus 16. We're told to use the quadratic formula to solve this. This is number 22 in your homework. And in my opinion, I think they've given you pretty bad advice. I mean, I wouldn't use the quadratic to solve this if I could help it, all right? But anyway, let's do it. We'll follow the book's instructions. We've got x squared minus 12x plus 20 equals to minus 16. So then one more step. X squared minus 12x plus 36 equals to 0. All right, so you can identify here the coefficients. We've got a equals to 1, b equals to minus 12, c equals to 36. So what's the quadratic formula look like here? Minus of minus 12 is 12, plus or minus the square root of minus 12 squared, minus 4 times 1 times 36, all right, all divided by 2 times 1. So x is 12 plus or minus the square root of what? Well, 12 squared, that's 144. I can do that, right? What's 4 times 36? It's 4 times 30. It's 4 times 30 plus 6 times 4, right? 120 plus 24. It's also 144, right? So we got 144 minus 144, which means that we've actually got what? The discriminant is 0 here. So the answer is just 12 over 2, which is 6. The answer is 6. Now, I say that the book is giving you kind of bad advice here because this is really not a problem that's well suited to the quadratic formula. Perhaps the point of the question is for you to see that sometimes a given problem has to be multiplied out and rearranged to be put in so-called standard form before you use the quadratic formula. Maybe that's the point of the question. But what's a better way to solve this once you have it in standard form? Like, can you guys tell me? Once you get to here, what if I didn't force us to use the quadratic formula, what should we do? Look at it. It's just x minus 6 times x minus 6, right? That's a pretty obvious factoring problem. So the answer is 6, right? This is always preferred if you have a choice over the quadratic formula, right? If the numbers are nice. Now, if the numbers aren't nice, well, don't fight it. Use the quadratic formula. Here's one where the numbers are far from pleasant. 0.17 x squared minus pi x plus, oh, I don't know, 32 equal to 0. I definitely don't want to try to factor this. I don't want to try to complete the square. It's just unpleasant to try to do any of those things. So let's just use the quadratic formula. Don't fight it. Use it. So here, quadratic formula looks like this. X equals to pi plus or minus, oh, what is pi? Let me just put the numbers in. Pi is about 3.14-ish. Plus or minus, it's minus pi, so I have a plus there. Plus or minus the square root of, minus 3.14 quantity squared minus 4 times 0.17 times 32 divided by 2 times 0.17. All right. So that's about 3.14 divided by, this is 0.34, plus or minus the square root of something divided by 0.34. What goes inside the square root there? We could figure that out, yeah? The minus doesn't matter inside the square root, does it? I'm cheating. Use my calculator. This calculator has a built-in quadratic solver. So, you know, I can find the answer just by plugging in the coefficients. But let me go through the motions here of doing the arithmetic by hand. Minus 11.9004-ish. It's kind of silly for me to keep that many digits when I'm only using 3.14, but whatever. You notice the minus inside the square root? That means it's imaginary, right? So what's the square root of 11.9? 3.45-ish. So I've got like 3.14 divided by 0.34 plus or minus I times 3.45 divided by 0.34-ish. And so 3.14 divided by 0.34, I get 9.24-ish. And 3.45 divided by 0.34, I get 10.15. All right.
So will we just put the complicated one, or just the two decimal places?
Oh, usually this kind of problem, I should really specify, like I just want an answer correct to, yeah, say 2 decimal places is good. If you're uncertain how many decimal places I want, ask me, I'll tell you. But usually 2 is sufficient. Now, this right down here, the reason I'm just writing that, I want to let you know how I got that. How did I get that? Because you notice I wrote this down before I did all that. Okay? What did I do? Well, in this calculator, the Casio 115 ES, there is a mode called equation mode. I hit 5, I'm in equation mode. The third one under that is quadratic equations. I hit 3, and then if I just put in A, B, C, in this case 0.17 minus pi, there's a button for pi on this thing, and 32, it spits back out at me 9.23 plus 10.14899792i for the first answer, and then I hit enter again, it gives me the second answer, the same 9.239978.393 minus 10.14899792i. So, yeah.
You still want us to show our work on the test, or are we able to just use that? Like, at certain. Can we go get one of those?
You are allowed to use this on the test, yes. This is not a graphing calculator. The one thing you cannot do is use a graphing calculator on the test, like a TI-84, a TI-85, an 86, a 92, a 91. I don't know. Scientific non-graphing. So this is a Casio 115 ES. Now this, it's the Casio 115 ES. This, I've taught physics a bunch of times here. This calculator served me well when I took physics because A lot of times you find yourself with an ugly quadratic equation and you just want to find the answer. Well, it's nice. You can just put the coefficients in and it does it for you. Because let's face it, these details here, right? The actual plugging in, the squaring, the subtracting 4 times the thing, keeping track of it, then taking the square root of all of that, and then you got to add it to subtract it from the other thing and then divide. There's a lot of steps in there, isn't there? And most of you, if you just try to do all those steps on a calculator, there's a high chance you make a mistake somewhere midstream, right? So to answer your question, you do need to show your work on the test. So while this is comforting that you can check your answers, it still doesn't change the fact that if I say solve something using the quadratic formula, I do want you to see you actually write down the formula and show me some numbers. Show me the digits. On the other hand, it is nice to be able to check your answer, right? Now, I think Walmart, so this is from like 10 years ago. I think Walmart has something, it's like, instead of ES, it's like EX or something. I think we bought one, my son, like a year or two ago. It's a little, I'm sure it's better than this. It's got some extra bells and whistles, but this also has all kinds of physical constants built into it. Like it's got mass of the proton, mass of the neutron, mass of the electron. All kinds of physical constants are in it. If you're in like a chemistry class, that's nice, you know. Anyway. And the TI-30 is also nice, but to my knowledge, the TI-30 doesn't have a quadratic solver built into it. I used a TI-34, I think, in my community college. I learned every single function on that calculator over the course of different courses I took over 2 years. Like by the end of those courses, I'd done every single button. It was something. I used to be pretty fast on that thing. Not anymore. All right, anyway. I am wasting our time. Sorry. Example 5. What if we had 6x squared minus 7x plus, oh, let's say, I'll put a minus 1. This minus 8 equal to 0. You're going to solve this one. So this one, I want to show you, I'm going to solve it by completing the square and using the square root property. Okay, this is how I'm going to solve it. Solve by completing square and square root property. Okay, so there's my instructions this time. So thankfully, we're not factoring, right? So we can discard the 6. I mean, if we were factoring, we'd just pull the 6 out and ignore it. But so divide by 6. I've got x squared minus 7/6 x. What's 8 over 6? 4/3, right? So minus 4/3 equal to 0. 8 over 6 is 4/3. All right, now time to complete the square. How do we do that? Oh, just to make it an x squared rather than a 6x squared. Just to make the arithmetic which follows easier. I didn't even want to try to factor it. I mean, you could try, but I just made it up just now. So the odds of us being able to factor it nicely are astronomically against us. If this works out so you can factor it nicely, it's just like God's perverse sense of humor at times. But let's see here. I don't know, we were just reading the story of like Jacob and Esau, and like the whole idea that he sold his birthright for like a bowl of beans. It's just messed up, right? Yeah. I mean, like in today's dollars, it's like millions and millions of dollars for a bowl of soup, you know, because like, I'm assuming Isaac had a lot of stuff. You know, Abraham was pretty wealthy after God blessed him, and I don't think it stopped for Isaac. Anyway, I digress. I just find it humorous. Okay, so, oh, I'm sorry, I was going to ask you, what's half of 7/6? 7/12, right? If we multiply a half by 7/6, what do you get? 7/12. Now, once I do that, I have to subtract 7/12 squared, which is 49 over 144. so these two terms I'm rewriting as those two terms, right? Just to be clear here, 7 over 12 times 7 over 12 is what? 7 times 7 is 49. 12 times 12 is 144. That's why I have 49 over 144 here. All right. Now isolate the square. We have x minus 7/12 squared equals 49 over 144 plus 4/3. Yeah, I moved them to the other side, but I hear you. All right, at this point, I'm tired. I'm going to cheat and use my calculator.
On a problem like this, so all you have to do with like the one right outside of parentheses, you just square it?
Yeah. Well, we have to subtract what we've added. And so by putting x minus 7/12 squared there, I have added 49 over 144. So to be fair, I have to subtract it. Otherwise, I've changed it. So that works out to 241 over 144. All right. So you can make a common denominator of 144 and then square root, square root, square root. This gives us x minus 7/12 equals plus or minus the square root of 241 over 144. But that is plus or minus the square root of 241 divided by the square root of 144, which is equal to plus or minus the square root of 241 over 12. So in fact, we have a common denominator of 12 everywhere. Solve for x, and we find x is equal to 7/12. Well, 7 plus or minus the square root of 241 divided by 12. Yep. I added the fractions. So how many times does 3 go into 144? 48. So 48 times 3. I want to believe. What is 48 times 3 is 144? Is that right? Yeah. 48 times 4 is 192 plus 192 plus 49? 241.
If there is a common denominator, is it just like universally?
As I said, I was tired, so I used my calculator, but that's good. What?
If there's a common denominator, is it like universally accepted just to combine the fractions, or is there cases where we wouldn't do that?
Well, I think we can always add fractions. So yeah, it's okay. I mean, like, I don't think there's ever a case where you cannot add the fractions. That sounds like a question for a math major, though. All right. Prove that you can always add fractions. Let's do it. You got a over b, right, plus c over d. Can we always add it? Can we always add two fractions to get another fraction? The answer is yes. We do the cross multiply thing. AD plus BC divided by BD. Now, so you can always fall back on that. But the reason I don't want to do that in this one is because then I've got to do 3 times 144, which is just making a mess of things, you know? So since 144 has 3 as a factor, we just need to figure out to multiply it by 48 over 48. We do have calculators. We could use them. Yeah. Oh, okay. Sometimes people stretch, and I misinterpret them as questions. So, but that was not a question. All right. Moving along. So applications. Applications of quadratic formulas. Let's look at some of those. So here's one. Example 6. Do there exist consecutive integers whose product is, I don't know, 14. So let's let one of the integer, we'll call it x. All right? What is the next integer? If I have 3, the next integer is 4, right? 3 and 4 are consecutive integers. So if 3 is x, how do I get 4? I just add 1, right? So what I need is I need x times x plus 1 equal to 14, right? Can we solve that? Well, it's a quadratic equation. We can try. So we've got x squared plus x minus 14 equal to 0. Student's choice, quadratic formula or completing the square? What do you want? Completing the square. All right. So to complete the square here, I take x plus 1/2. That's the responsible answer because you guys need more work on completing the square. Thank you for giving me that answer. Because everybody can plug numbers into a quadratic formula, right? But completing the square might be a thing you're learning now. So if I have x plus half of 1 is a half, right? Now to be fair, I have to subtract a half squared, which is a quarter. So that gives me x plus a half quantity squared is equal to a quarter plus 14. But I'm going to rewrite 14 as 56 over 4. Because 4 times 14 is 40 plus 16, which is 56. And so that's 57 over 4. It's not looking good for our integers here. So x plus a half is plus or minus the square root of 57 over 4, which of course is plus or minus the square root of 57 over 2. So the answer is x is equal to minus 1 plus or minus the square root of 57 over 2. Now you can plug these numbers into your calculator. What are you going to get? We will get 3.27-ish, or minus 4.27. Are those integers? Well, what's an integer, right? So that's really the question, isn't it? Let me remind you, integers, we denote the set of integers, right? Usually mathematicians use this symbol for it. So it's like 0, plus or minus 1, plus or minus 2, plus or minus 3, and so forth. These are the integers. Whole numbers and their negatives, integers. Are these integers? They are not. So the answer to the question is, nope. You can't find consecutive integers whose product is 14. It's easy to make this problem work out better in the sense of having a more satisfying answer. But when I do that, all of a sudden you guys will be able to guess the answer immediately. So how about, oh, I don't know, 42. Can you find a product of successive integers whose product is 42? Can you guys tell me? 6 and 7, very good. So then you're like, well, we don't need algebra for that, right? Yeah. But 6 and 7 is a good answer, but notice what happens here. We get x squared plus x minus 42 equal to 0, which gives us x plus 7 times x minus 6. I'll get out of the way here in a second. In contrast to my ugly problem, which helped us gain more experience on completing the square, this one, we can factor. Woohoo! And the answers are x equals minus 7 or x equals to 6. That makes x plus 1 equal to minus 6 or x plus 1 equals to 7. See, so the answers are minus 7 and minus 6 or 6 and 7. There are two answers. And everybody thinks of the 6 and 7, right? But less people think of the -7 and -6, right? But those are also consecutive integers. So that's the nice thing. If we set up the mathematical problem logically, the algebra will find all possible answers for us. If there are more than our intuition gives to us, math will find the rest. Which is kind of neat. You know, every so often, physicists don't do the math. And what happens is they have like a partial derivation of something, right? And if somebody with authority does that partial derivation, the physicists who come after him line up like so many lemmings and follow him. And they say, oh yes, this is the correct derivation. The master has given it. And then it might be a long time before somebody else comes along and says, you know, you haven't really done the math there. And then when they do the math, they might find something physically new. This has happened. There's something called Berry's phase in quantum mechanics. There was a derivation of something called the Adiabatic Theorem, which they did in a one-dimensional sense. After about 50 years or so, somebody came along and said, if the thing you're doing is not one-dimensional, it could be higher dimensional. That integral could have what are called topological effects in it. This happened in about 1980, and a guy named Berry did it, and he discovered what we now call Berry's phase. This led to all kinds of advances in optics. Like thousands of papers have been written about this, all because somebody did an integral in a one-dimensional sense when they could have done it in a higher. So like not doing the math and just assuming the answer is what it should be because you could guess it, it can be detrimental. A lot of advances in optics and stuff have come from that. Anyway, what example is on? 8. All right. Okay, so here's another one for you. All right. You got a barn door. Oh, I did this one already. I'm kind of bored of it. You're like, I haven't done it in here. Well, Oh, fine. I'll do it for you guys too. You got a barn wall, all right? You're told that the area of the barn wall is 252 square feet, all right? You're also given this sentence. The length is 10 feet longer than twice the width. All right? So let's suppose this is the length and this is the width. The question is, what are the length and width? All right? How do you solve this? Yeah, he said develop a formula based on the sentence. I like that. So what would that formula be?
Since the length is the one that has everything attached to it,
Uh-huh.
it being 10 feet longer than twice,
Okay.
we can use the width as the base of the x.
Oh, I said well, I mean, I hear you, but I'm going to say 2w, right?
Okay, yeah.
Plus
Plus 10, yeah.
plus 10. Now you're saying you would make w equal to x. Not opposed to it. That'd be fine. You could call L equal to x. I mean, w equal to x if you want, fine. But in fact, I'll do that. Why not? I like it. Then I'll do algebra in x rather than w. So, yeah, fine. Why not? Then what? The area is what? Length times width, right? But the area is given to be 252, and the length is 2x plus 10, and the width is x. So, again, a quadratic equation, right? Pretty much all of the application problems in this section come back to quadratic equations, okay? So, so multiply it out, what you got? You got yourself 252 equals to 2x squared plus 10x, which we could rearrange to 2x squared plus 10x minus 252 equal to 0, right? Divide by 2. We've got x squared plus 5x minus 126 equals to 0, right? Let's take a look at 126. It's equal to 2 times what? 63. What's 63 equal to? Remember? 7 times 9, yeah? So how can I get a 5 from these numbers? How about, what, you say 2 times 7 can be 14, right? 14 times 9. Well, 14 minus 9, that's 5, right? So this suggests we can factor this. X minus 9 times x plus 14. You're like, well, that's lovely, it worked out for you like that, but I wouldn't have seen how to factor that. Hey, that's fine, what could you do? You could use the quadratic formula. You could complete the square. Those are foolproof methods, right? If you know them. If you don't know them, they're not foolproof, right? Anyway, so what do we got? We got either, what's your choices here? X equals to 9? Or x equals to minus 14. Can x be minus 14 in this context? No, x has to be 9. So this gives us the width is equal to 9. The length is equal to 2 times 9 plus 10, which is equal to 28. So basically the dimensions of the door of the barn door are 28 feet by 9 feet. 28 feet by 9 feet, them's the dimensions. Although I think the homework has two things, one for length, one for width. You just put the numbers in there, right? Okay. This one's moderately difficult. Yep.
So was the question for this, like, find the length and width?
Yeah, the question was find the length and the width of the barn door. Oh, what am I doing? The shirt. All right. The next problem, I think, is honestly, like, to me, this one's more challenging. So let's look at it together here. Example 9. So you got a room. You got a room, and the dimension of the room is given. All right. The room has a certain length and width which are given, and I'll use the numbers in my homework here. I got 21 foot. And down here, 27 foot, all right? 21 by 27. And then I'm also told that we're going to put a carpet in the middle. Sorry. That's okay. It hit the trash can, that counts. Let's see here. So you got a carpet you're putting in the middle of the room, like so. All right, and not like my picture. It's a rectangle, a perfect rectangle. And this is a uniform strip. All right. Then the question is, what dimensions do the carpet have? Now, I forgot to write a number down here. The area of the carpet is given. Like, you want to buy 187 square feet. Maybe that number has some sort of sentimental reason to you. I don't know. You're like, the decoration in this room, it's killer, right? It's a murder. Let's see here. 187. All right, so what should I do? What should I do? How do you find it? How do you find the dimensions of the carpet? I mean, you want the length and the width of the carpet, right? But I think those are not good choices for the variable here. What's really, to me, the question is, what's the width of the strip? right? So I'm going to call the width of the strip x and go from there, see if I can put it together from that. That's not given in the problem. That is a creative leap, all right? So I'm going to say that this distance right here, this distance right here is x, right? And it's a uniform strip, right? So this distance over here is also x, okay? So the real question is, what's this length, right? And what's this width? So let me make a little observation here. If we kind of just draw up here, see this distance here is also x, right? This distance here is also x. But altogether you've got what, 27, right? So what does L have to be? I mean, L is also here, right? So you can see that x plus L plus x has to be 27, right? Which means that L has to be 27 minus 2x. Now, some people just see that looking at the picture. Some people have to derive it, whatever. What's the width then? Same principle, right? It's 21 minus 2x, yeah. And now we've got it, right? We know the area is equal length times width, which means 187 is equal to 27 minus 2x times 21 minus 2x. Everybody with me? By the way, this is essentially number 29 in your homework. If you're keeping score. All right, so you multiply this thing out. You got yourself a 567 minus 42x minus 54x plus 4x squared, which gives us that 567 minus 96x plus 4x squared. I'll work on it up here. We've got 4x squared minus 96x plus 380 equal to 0. Divide by 4, right? Divide by 4, what do you got? Divide by 4, we've got x squared minus 24x plus 95 equal to 0. And you're like, 95? Well, 95 is 5 times 19. So obviously this is x minus 19 times x minus 5 equal to 0, which gives us x equals to 19, or x equals to 5, right? This one works out pretty nice. Now, which of those is the answer? Is, think about 19 for a second. Could you take a 19 strip here and there? You've only got 21 to work with. You can't take two 19-foot strips off the room, you know? I mean, you can't do it. Now, you could also see this. Somebody pointed out in the last section, if you put 19 back into the formulas for L or W, you get a negative number. That's also a dead giveaway. But certainly we can use the 5. 5 is good. And so that gives me the length is 27 minus 2 times 5. The width is 21 minus 2 times 5. So that's 17 and 11 respectively. So the dimensions are 11 foot by 17 foot. That's the answer here. Like I said, I think this problem's, you know, a little bit challenging. A little bit. All right. So I wish I didn't have to go to Alabama to sell my house, so I won't see you guys Friday, because I'd like to have more time to talk to you about in person the next kind of problem. Let's just do one. We'll just do one more example today. This is from the last, so the last section is on, you're gonna miss me? I'll miss you too. Miss you too.
I'm coming here for like, oh.
You guys can come in here and help each other out if you want, like, you know, do problems and such.
Anybody gonna be here Friday?
I'll turn my head. I won't see it. I knew it. Rats. All right, so
Just want to throw a party. Somebody bust up in here. Oh, everybody doing that.
other equations. So the other equations we still need to talk about is like how to solve stuff like x over 2x plus 3 equals to x plus 2 over x minus 1, things like that. Or you might have like the cube root of 3x minus 7 equals to 2. How do you solve equations like this, right? But the one I'll work for you guys right now is one that I will pick from my homework sheet here. Listen, so I'm going to solve a bunch of these tomorrow in the Thursday section. All right, but I just want to do one here with you guys before we leave. All right, let's see if we can solve this one. By the way, so in this case, this 19 is what's called an extraneous solution, right? Okay, let's see what happens here. So I asked the last class, what do you do if there's unrest in the streets? Like, what do you want to do? No, if there's unrest in the streets, what do you want to do? You're the government. You want to isolate the radicals. Right? Isolate the radical. So you isolate the radical. So there we go. We've isolated the radical. And then what do you want to do with radicals? You want to turn them into squares, right? Members of the establishment, right? This joke is really requiring your grandparents, maybe. I don't know. We used to call people who were not, fashionably hip, they used to be called squares, right? So square both sides, you get rid of the radical. So you got x squared equals to 15 minus 2x. And that is x squared plus 2x minus 15 equals to 0. I think we can factor that one. Can you guys factor it for me? What's that? 5 and 3. Which one gets the plus? Which one gets the minus?
5 is a plus, 3 is a minus.
Very good.
X equals -5 and 3.
So yeah, so x equals minus 5 or x equals to 3, right? Now with this kind of problem, you got to go and you got to check, all right? So let's check. We take minus 5 minus the square root of 15 minus 2 times minus 5. What do you get? And then we try 3 minus the square root of 15 minus 2 times 3. What do we get? The top one, we get minus 5 minus the square root of 25. The bottom one, we get 3 minus the square root of 9. Now 3 minus the square root of 9 is 3 minus 3, which is 0. No problem there. Woohoo! Now this one, we get minus 10, which is not equal to 0. So what's that mean? It's extraneous. Which one's extraneous? The bottom one. Which one? What did you say? The negative 5. This is extraneous right here. Now, I told you I talk about my career as a rapper, right? So I always tell people that if I was to be a rapper, I would be extraneous G. And then my tagline would be, I'm not even in the solution set. See how it works? Yeah, it works. But you like that? Yeah. Anyway, more on those.